I'll put the transformer right here, the secondary of the transformer. Here's the center tap. Most, you can buy, the center tap doesn't really cost you anything when you buy a transformer. You can buy a center tap transformer just about as cheap as you can buy a regular on top center tap. So I always get it, I have the center tap, and if I want to use it, I can. If I don't worry about it. So, I'm going to go ahead and put this in color. I just kind of want to have a little, kind of a neat drawing here. Now here's what happens. If I put that diode in like that, the one that's opposite of it has to go in the same way. So it goes like that. That's how you see it in there. And then so these two will be conducting at the same time. We'll call this D1 and D2. And then the other two diodes, if this diode goes in with anode, you've got to make this diode the cathode. And if that cathode's facing that direction, this one has to face the same direction. Yeah. So now, the reason they call this a bridge, if you look at this resistor out here, which is the load resistor, this is RL here, load, and then this will be the voltage out, VDC equals whatever. And so this I'll do as black also. And I want to make sure you understand there's no connection there. And then ground is right here. I just use red, you know, it's probably right down. The other one is chassis ground, but that's all right. Now, the center tap, I'm going to leave it floating. I'm not going to connect anything to it. It's not needed. I showed it there, but it's really not needed. Anyway. These two diodes come on at the same time. And they're going to come on when the input is positive. And we'll make our input positive right here. During that time, thank you. Did you get it off?
The speaker's off.
Okay, yeah. All right. When this is positive, now watch carefully. We know that this diode is going to be on. When this is positive at the same time, down here at that same time, what's going to happen here? That's going to be negative. So I'll go ahead and put it there. That's going to go negative during that time. And you can see that negative is going to make this one off. That positive there is going to make this one on. And we'll see about the other one here in a moment. So during the positive, these are going to conduct against the arrow, right? The current always flows against the arrow. And so, that is that right there. And you can see, since this is negative right here, that negative appears right here. And that shuts that one off. I'm sorry, that negative turns this one off and turns this one on because it's negative at exactly the same time. So, here's the path then. You just find it. We're going down the transformer. There's no center tap, so we come through here. And what's going to happen there? This one's off, that one's on, so it's going to go up through there, right? And then, since this is positive here, that's positive right here, that turns that one on, and this one is off. Everybody see that? It's off. Everybody see why that's off, Jeff?
I'm sorry, I was in the
This dial right here,
middle of drawing here.
this is positive up here. That plus makes this cathode positive and this anode positive. That means this one's on and that one's off. That makes sense?
Yeah.
And down here, since this is negative, at the time this is positive, this negative turns this one on and it shuts that one off. So these two are on at the same time, those two are off at the same time. So here's the path. It comes down, it starts here, we go down through here. It's gotta go this way. That one's off, so it forces that down through here, up through here, and to there. And notice current's flowing negative to positive. That makes this positive. At the same time, this is negative. So, all that says is that when this is positive, 0, the output's going to be positive. And assuming this was a 2-to-1 transformer and this was 120 volts here, this would be 60 volts across that secondary, which has an RMS of, an average of 54. So this wave right here, with 60 volts RMS, has an average of 54. All right, let's look at the next half of the cycle. When this goes negative, at the same time, what's happening down here? It's going to be positive at that time. So it's right there. That's positive. Whoops. This is the end of the transformer, so this is positive down here. And that's negative. So which ones are on? Well, now the blue's on, and you'll see this is positive. That shuts this one off. And this negative on that anode shuts this one off. And it turns, that negative turns this one on. And this positive turns that one on. Current's going to flow against the arrow. And against the arrow here. Get this out of the way here. All right. And let's just look at the path now. When this is negative, we got current flowing in this direction. This one is off, so it forces it down through here. Notice the current did not change directions. Whoops, go here. Because this one is off, forces it down there. And the current's flowing up, negative and positive. And down through here. And we're connected there, up through the transformer. And there. Now, it's a little nasty looking, isn't it?
Yeah.
And I didn't do a very good job there. Art's not always perfect. But that just shows you that both of those are on, and when these are on, it uses the entire secondary, and therefore, during the negative part up here, like that, this is going positive like that. I'll make it same size as the other one. Like that. And what's this average?
54.
So what's the voltmeter going to read?
54.
54. That's pretty good. We're only 10% less than the RMS. Instead of like 50%, we're now only 10%. So you can see adding a couple diodes Now we're getting a lot more efficient, aren't we? Everybody see why that's 54? The RMS is 60, 2 to 1. And average is just 90% of that, 6 times 9, 54. And since it's a full wave, and we're using the entire transformer, at least we get twice the voltage we did with a 1 or 2. Because with 1, we lost half the wave. With 2, we lost half the transformer. We had to use center tap. With 2, you always have to use the center tap. That means you're going to cut the voltage in half. But still, the DC doesn't look too good. Why don't you go back at 7:15 and we'll do a couple examples on this four-way bridge, because this is the guy, obviously, that we want to deal with, isn't it? If we want the best, most efficient power supply, we got to use that one. And for the cheap price of diodes, a couple diodes more, you're going to do nothing in terms of cost.